Hey guys, we're going to be looking at matrices and data today. So I've got a couple of examples. Okay, to keep the videos short, I won't necessarily describe or even read the problem, but you can pause and look at it in that detail. Okay, we're going to just jump in here. So we're looking at a problem involving matrices. Okay, so here you'll notice a number being multiplied to a matrix. So this is my scalar, okay, for scalar multiplication. So I simply multiply 9 times 4, 9 times 4. So excuse me. Alright, now the next thing I'm going to do is I'm going to multiply this 6 into this, and this 6 into this expression. Okay, so I have 6 times negative 5 is negative 30. And I have 6 times 2 minus x, which is 12 minus 6x. Okay? And we'll leave this alone for now. Okay. Next, what I'm going to go ahead and do here, pay attention, is I'm simply going to verify that indeed I have, at least here on the top, as I have, watch this. Okay. I've got 36 plus negative 30. Okay, equals 6. Okay, so that's true, so that checks out. This next one I have 36 plus 12 minus 6x, and then there's a 36 here. Okay, so this top one's already done, it's equal to, but let me go and continue here. Okay, it's almost like two equations, two problems separately. So now I do the math there, so as far as that goes, I have 6 equals 6. Okay, as far as that goes. On this next one, okay, what I have is 36 plus 12 minus 6x, so 36 plus 12 is 48 minus 6x, okay, equals to 36. And now since the top is already done, okay, what I can do here, okay, I'll start it so I can kind of solve for x, which is what I was asked to do, right? Solve for x. So I can continue with this notation, and as a matter of fact, I'm probably going to do so towards the end at least, so we can return to matrices. But for right now, since the top's done, really this equation is my only focus. Okay, so I got 48 minus 6x equals 36. Here I can do a couple of things. What I'm going to do is I'm going to subtract 48 to solve for x. I now have negative 6x equals to negative 12. And long story short, you guys know here that x is 2. Okay. So that is indeed how you would go about solving this problem, okay, for x. So, what did it ask? Now, of course, if it asked to prove, I could simply plug it in and I'd be done, okay? Alright, next problem. And that one was the tougher of all of them. Okay, I just wanted to get that one taken care of first. These next ones are a lot easier. Okay, this is more your focus for tomorrow's warm-up quiz. That other problem, we can kind of postpone it, but you do want to have it in your notes. Okay. Alright, so this one has two source carry small, medium, large sweatshirts, table shows inventory starts, but data matrix, give the dimension of the matrix. Okay, so here what we're going to do is, okay, we're going to introduce data into a matrix form. So notice that I have 3 columns and 2 rows. Okay. So what I'm going to do here is, since I need 3 columns, okay, I'm going to, let's see if I can do this kind of this way. Okay, 1, 2, 3. Alright, and as far as rows, I got 2 of them, right? So I'm going to go 1, 2. Okay, so basically the 12 is the, right, first, so all these are in the first row. First column is 12. Okay, I'm talking about the first row right now. Second column is 20. and third column is 18. Okay, let's go ahead and now list the second row. First column is 16, second column 34, and 25. So now this data has been entered into a matrix form and we're done. Okay, what we can do is give it a name. Okay, just in general, A works. Okay, for matrix A. Alright, this next one says add these two matrices. This is a lot like the first one, but a lot easier. Okay, so it'll go ahead and follow with me. Now, one thing I do want you guys to pay attention to is that you'll see that this guy's in the, all these guys are in the first row. Okay, all these guys are in the first row. So only the 8 is in the first row and the first column. He's in the first row and the first column. So when it comes to adding them, check this out. It's 8 plus 5, 13. Okay, and I'm going to do the same thing here, like this. Okay, first, second, third column. Okay, he's got 3 columns, he's got 3 columns. And he's got 2 rows, he's got 2 rows. So I'll go like that. Okay. Now what I'm going to do here is I'm going to add each corresponding entry. So, right, I'm going to deal with all the first rows. So he's in the second column 2, second column, so 2 plus -3 is -1. And I have next 4, right, third column, 8 in the third column, so 4 plus 8 is 12. Next I'm going to deal with the second row. First column is 3, first column is -4, so 3 plus -4 is -1. And I've got 9 plus 6 is 15. That was my second column. Now my third column is -10 plus -8 is -18. Done. Okay. Now this one here says a movie theater marks up tickets by 120%. Okay. So it says use scalar product to find the marked up prices. So this one again is related to that first one that I showed you guys. So here's kind of what this would look like. Alright, we're going to take the data like we just did on the last problem and insert it here. Okay. Now notice here we have 2 columns, so it's 1, 2, and 3 rows. 1, 2, 3. Okay. Next, I'm just going to enter these values. So 4, 6, 5, right? 4, 6, 5, 6, 10, 7. Whoops. 6, 10, 7. So I've taken this data and entered it into a matrix. Now it's saying but these movie theater tickets were marked up by 120%. So what this does is, okay, use scalar product to find the marked up price. Okay, so we basically are going to have to take this plus the markup. Oops. Okay, the markup of these same values. So check this out: 4, 6, 5, 6, 10, 7. Okay. Now again, since there was a price increase, it's still this original price plus the increase, which is what, 120%. I can put probably 1.2. Okay. So what I do now is just the math. So let's see if my calculator's up and running here. Okay. So I'm going to need to take 1.2 times all of these values. So let's go and do that. Okay. So I'm going to keep this one intact. 4, 6, 5, 6, 10, 7 plus. Okay. Here's this guy's going to get multiplied into each one of these entries. So I've got 4.8, 7.2. I've got 6. Okay, and again, I have the calculator ready, but I'm trying to do this in my head to kind of speed up things here. 7.2. Here we're going to have 12. And here we're going to have 8.4. Okay, so this scalar multiplication has essentially vanished, and now I can add these matrices to get this total sum. So I got 8.8, right? This, I'm going to do the first rows nice and slow here and then speed up. So first row with the first column. So there's that, and then this guy, right? Second column, that gives me 13.2. Next, okay, trying to anticipate what I'm going to do. I'm going to get 13.2, 6 plus 7.2. Now it's 10 plus 12, which is 22. I'm going to do 5 plus 6, which is 11, and 7 plus 8.4, which is 15.4. Okay. Now notice that I'm not going adding 4 and then down here. It's got to be in the corresponding entry. Okay. First row, first column. First row, first column. And lastly, evaluate B plus C. Okay. These, all you would have to do is add them. So let's go ahead and do that here for you guys. 2, 8, 7, negative 6. So this is actually an easier version of this last problem. 0, 1, 4, negative 2. Now those of you guys taking really good notes, make sure that if you are going to add matrices, that they have the same amount of rows, 2, 2, and the same amount of columns, 2 and 2. If there's not a match, you cannot do so. Okay. So here we're going to have 2 plus 0, 2, 7 plus 1 is 8, 8 plus 4 is 12, negative 6 plus negative 2 is negative 8. And that takes care of that. Okay, so we've got that. We did this one, we did this one, and that's it. Thanks for your time.